Hi folks, welcome to our impulse generator lecture. We have already talked uh, 4 lectures, if I'm not mistaken. Yeah, for in chapter 7, and last lecture also we devoted to the impulse generator. Today also we will talk about the impulse generator. As I mentioned, impulse generator is a, in fact, if you have seen the composition, it consists of just two. Uh, Simple generator consists of one capacitor, two resistors, and a source of DC voltage and a sphere gap. It's a very simple circuitry, but it's a very interesting uh, equipment, and it has improved. I mean, the main problem was the measurement. What we will come next in the next chapter. uh, what Even the design of impulse generator has improved like anything, and you can also imagine, as we increase the transmission voltages, the switching surges rise proportional to the rated voltage. So we need to test our equipment in the network with high switching voltages, and high lightning impulse voltage are produced till up to maximum 7200 kV, and the switching which is desired to be more, but it has it is doing its job for the highest voltage, that is of 5000 kV switching impulse voltage, which is slower and which needs the size of the component or the ratings of the components of the impulse generator to be larger. So we made a derivation about the energy rating of an impulse generator, which is higher in energy rating is required for higher capacitance testing. I mean, when the capacitance of the test object C2 is higher, we need higher rating, and the higher rating we can obtain here, as you can see. Uh, uh, yeah, I'm not right. No, it's not right. Anyway, uh, when C1 is increased and U naught maximum is increased, which is limited because of the constraints we have, we'll be talking more about it. And as you can also see here, the efficiency part, the efficiency is C in the bottommost in this slide, bottommost line, C1 upon C1 plus C2. So for higher efficiency, C2 by C1 should be as small as possible. That means C1 should be as large as possible. C1 is the capacitor which is installed in the impulse generator. So for getting higher efficiency, you must have higher capacitance, uh, capacitors installed in each stage. We'll learn about the multi-stage generator in each stage. And to increase the capacitance of a capacitor is also needs a technology. I mean, what forms the capacitance? It is nothing but insulation. So we need capacitors having dielectric of higher permittivity, of higher permittivity. Hmm? It- So that is the requirement for some uh, for the for a good impulse generator. Not what. Can we do that? Just a minute. Some adjustment. Sorry for the interruption, but the pen was not working. I was talking about the efficiency, and efficiency increases when you have higher value of capacitors installed in the impulse generator, and the higher value of capacitance in a small volume you would like to achieve, that is obtained only when you have a dielectric of higher permittivity. You know, the permittivity, higher is the permittivity, more is the capacitance formed by a dielectric. Now, we did also talk about, yeah, this was, wait just a minute, the, and we derived, I mean, you can also, you do it yourself. The output voltage of the impulse generator is given by this equation number 6, where the constants are being mentioned. And when we plot this equation, the two parts of the equation, we get the resultant wave in this way. This is the resultant wave, and that is what we want. And as you can see, 1 upon alpha 2, the time constant, determines the rise or the wave front of the wave, and 1 upon alpha 1 time constant, that is alpha 1, determines the decay, and which can be then the whole circuitry can be designed in such a way that the time required to reach the peak and decay to 50% value as defined is of your choice. Here we also mention, I said I will give you next time the efficiency, as you can see it here. The efficiency works out to be this way. Efficiency is given by the peak output voltage upon the charging voltage. This we are talking about simple single stage or simple single circuitry of the impulse generator. U naught is the DC charging voltage, and UP is the peak value of the impulse voltage output. So this works out to be the last time there was some problem. You can also work it out yourself. This works out to be alpha 2 by alpha 1 to the power of minus alpha 1 upon alpha 2 minus alpha 1. Alpha 2 minus alpha 1. Minus again alpha 2 upon alpha 1 to the power minus of alpha 2 by alpha 2 minus alpha 1. So this is the numerator of the equation, and in the denominator is k multiplied by alpha 2 minus alpha 1. So this is the efficiency, which is equal to, as I mentioned, U peak value output upon U naught. So the UP is being given here in this diagram, is determined like that, and the time required to reach UP, that is the maximum time required, T max, will be given by alpha 2 by alpha 1 upon alpha 2 minus alpha 1. Yeah, so this dimensioning, then what is needed is the dimensioning. That means for your desired uh, shape, that is time required to reach the peak value and decay to 50% value, what should be the values of R1 and R2? Because R1 and R2 determine the time or the shape of the voltage. The capacitance does not come into picture. In that case, capacitance determines the energy of the generator. So we have talked about in the last lecture for dimensioning of single stage impulse generator. R1 and R2 can be worked out like this. Yeah, the C1 and C2 do come into the picture, but the uh, main component would be R1 and R2, the total value of R1 and R2. So, uh, as you for T1 and T2, the dimensioning is done in this way. The time constants have been worked out. Alpha 1 and alpha 2 have been worked out, as you can see it here. The alpha 1 and alpha 2 for uh, 1 upon alpha 1, 1 upon alpha 2 for a wave shape of 1.2 by 50 microseconds. That is your a lightning wave shape. The 1 upon alpha 1 and 1 upon alpha 2 are given like this in the table. And for the standard switching impulse voltage, single shape. There may be more shapes, but this is the shape 250 by 2500 microsecond is the most general wave shape of switching transient uh, surge, and the constants work out to be 1 upon alpha 1 to be 28727, yeah, and 1 upon alpha 2 is equal to 104. So when you know these values of alpha 1 and alpha 2, you know in the circuitry what is the value of C1, C2, then you can work out R1 and R2. Good. Now, you can imagine every time you want to produce different wave shape, R1 and R2 would work out to be different. So you have to put new resistor R1 and R2, new values of the resistor. That means um, physically different resistors you should be able to put it in the circuitry. We should take it out the old one and put the new one, the desired value. So you must have a bank of resistors to be able to produce different wave shapes by the same impulse generator. Now, you can imagine now when you have number of stages put together, one after the other in cascade, in every stage you must change R1 and R2, which is not a simple job to do it. You'll see the dimensions of this generator. They are so large and changing. There are, I'll show you in a picture, there are 36 stages of the single circuit, single stage generator. 36 of them are put one after the other, one above the other in cascade. And you have to then change R1 and R2 in all 36 stages, which is a very, very complicated process. Yeah, the multi-stage generator. Let's talk about, because single stage generator, as I was mentioning, are limited up to 300 kV. There are limitations. Why? The main limitation is the component size increases. If you want to produce higher output voltage, you will need higher uh, input voltage, that is the DC supply. You will need bigger uh, sphere gaps, because you want to produce the breakdown in the sphere gap, which makes the circuit continuous. And for higher voltage, for breakdown at higher voltage, you need larger gap distance between the spheres, and to remain within the weakly non-uniform field, to be able to get the performance of sphere gap exactly at the same, I mean breakdown occurring at exactly at the same voltage, you need to put higher dimension spheres. All these things limit the single stage generator to be up to 300 kV. Even 300 kV is a very very rarely used. Mostly it is 200 kV and 250 kV circuits are cascaded. So uh, the schematic diagram of max circuit and modification are shown in figure. Mm, let's see, are they there? Yeah, this is the max circuit. As you see, may not with the modification. This is the max multiple multi-stage impulse generator uh, with wave tail and front resistors in each stage. So this is the multi-stage impulse generator looks like to be, and this is nothing but a max circuit. Max circuit, can you imagine when was it first suggested by Ma- Marx? Sorry, I was Marx, not Max. Marx in 1923. It was first suggested in 1923. This uh, this you can omit. This you can omit, and the gaps spacing between the sphere gaps is chosen such that the breakdown voltage of the gap is greater than the charging voltage. I mean, you can the sphere gaps put in each stage. Now, when we are talking about a multi-stage, each stage would have identical sphere gap, and the setting is done in such a way that the gap distance is set for higher voltage required for breakdown. That means when you set a gap and you set a voltage, at that voltage it should not lead to breakdown. We require techniques to produce breakdown at exactly the same voltage or exactly the same input voltage, to be able to get the exactly same magnitude of output voltage. You must have the breakdown, I mean the circuit is charged to a particular value of input voltage, U naught. And so you must set the gap distance in the sphere gap to be of the order of when the on applying a certain value of U naught, no breakdown takes place. So you need an extra mechanism to produce the breakdown. We'll discuss that. Then also, when you set the gap distance in these multi-stage generator, You can imagine in the first stage, let's say each stage is designed for 200 kV. So you put the voltage, and all the stages, charging capacitor of all the stages are charged at the same potential, same DC potential. Suppose it is 200, you want a 200 kV output, which is the maximum maybe of a stage. You want to charge, you have to charge, say, 100, something like 100, and you may need to charge it at UP by U naught. U naught is higher than UP. Suppose for single stage, you may have to charge, say, about 210 kV. So each stage is charged at the same potential. Or you can say the charging capacitors, let's see the diagram. In each stage, this is R1, R prime is the charging capacitor. R prime is the charging capacitor. Yeah, R prime is the charging capacitor. And each stage is having the same magnitude of charging capacitor. Then each stage was, all the stages are identical. There is a charging capacitor, C1 prime is the charging capacitor in each stage. And then the shape determining resistors, the R2 prime, that is the stage wave tail resistor, R2 prime, as you can see it here. And then R1 prime is the stage wave front resistor, as you can see it here. Towards the end of the last stage, you may or may not have another resistor, R1 double prime, that is external wave front resistor. R1 double prime is known as external wave front resistor. You may have it or you may not have it, depending upon what is the total R1 R1 you want. What is the total value of R1 you want? You may need it, you may not need it. Now, in this multi-stage generator, as you can see, all the capacitors are charged, C1 prime are charged in parallel. And what forms a single stage? I'll just circle here. This forms the one stage. Yeah, this forms one stage. That means the charging capacitor, the wave shaping R1 and R2, the wave front and wave tail shaping resistors, and we need, for the safety of the charging capacitor, a charging resistor. This was not there when we explained the single stage generator. So there are, see, each stage has got 3 resistors, 1 capacitor, and an air gap. That is the sphere gap. Now, when the sphere gap is open circuit, when the gap distance is at G is wide enough, you are able to charge C1 prime, isn't it, this stage? And when you increase the voltage for a particular gap setting, just above that voltage, the air gap would lead to a breakdown. That means the air would break down. Then what happens in that case? You can then mention that in the what would be the voltage at different locations. So the voltage will be, just a minute. Here at this point, the voltage will be, when you are charging with negative, mind it, when you are charging with negative DC potential, negative U naught, then the voltage at this location, as I am mentioning, will be positive polarity. You can derive, you can get convinced that the polarity of this point will be positive polarity. Now on the second stage, the the uh, input voltage was the same for C1 prime. Now when the G1 has short circuited, that means the circuit is continuous. U prime, where, sorry, U plus will be the voltage impressed at this point. Now when across the C1 prime, that is the charging capacitor of the uh, second stage, what will be the voltage when at this point it is U plus and you were charging it at U minus. So the voltage across this C1 capacitor would be, for an instance, to be 2U, isn't it? And as soon as 2U is impressed across the second stage sphere gap, this point will acquire 2U, and minus U was already there. So the next junction will acquire 3U. So the output voltage becomes NU times. This is how, in fact, what is happening, you are charging all the C1 prime capacitors in parallel, and when the first gap triggers, triggering in subsequent stages of the gap would also take place, because large voltage is added there, larger voltage is applied, then obviously the second stage air gap or the sphere gap would have a short circuit, would have a breakdown. So you have to just begin the triggering at the first stage. In the next stages, the breakdown at the sphere gaps takes of its own because of the increase in the voltage. And ultimately at the last stage, you get a voltage of NU times. So you had applied U time, the voltage in the first stage to be U, and in the last stage you get, depending upon the number of stages, NU times, and which is being impressed upon the test object. This is C2 is the test object, as you can see it here. So that is how the multi-stage generator works. That means you charge the each stage capacitor C1 prime in parallel, and when the short circuit is taking, that is, you can say the short circuit across the sphere gaps is taking instantaneously. So the discharge process begins as soon as the short circuit takes place across the sphere gap in air. Breakdown in air takes place. What will be the condition of all C1 prime, the charging capacitors, at the time of discharging? At the time when there is no breakdown across the sphere gaps, all the capacitors are being charged in parallel and holding the charge. When the breakdown is triggered, breakdown begins at single stage, it continues immediately to all the stages, and under breakdown, after breakdown, the C1 starts discharging, and then what will be the circuit between uh, the charging capacitor of first stage and the second stage? These will be discharging in series. So you charge the charging capacitors in parallel and discharge. The circuit makes them discharge in series, and in the process adding up the voltage. I hope you give a thought, and if needed, you can also read again from our book, and it will give you the understanding in a better way. So let's talk what have I written here. The gap spacing is chosen such that, here I'm talking about this point, the gap spacing is chosen such that the breakdown voltage of the gap is greater than the charging voltage U. It should be U we have taken. Thus, all the capacitances are charged to the value of, you can say, U naught. We charge them to a value U naught. And at U naught, uh, yeah, you can charge, or not necessarily 1 minute. You can charge a few seconds. It takes time to acquire the voltage across the capacitor. So at U naught, you hold the voltage, and the setting of the air gap is such that no flashover takes place at the air gaps. Okay, and when the impulse generator is to be discharged, the gaps G in each stage, the G, are made to spark over. I mean, they would spark over simultaneously uh, by some external means. That means we give a triggering pulse, what we call it to be a triggering pulse, with the help of a very interesting gadget, which I'll describe for you today. Triggering pulse is given. You hold the charge on each capacitor in each stage. Then at the first stage, you give the triggering pulse, and subsequent stages would have flashover of their own, because the voltage multiplies in the next stages. It adds up in the next stages. So higher voltage will be applied in the next stage, and still higher voltage across the sphere gap in the third stage. So when higher voltage is applied, obviously the flashover would take place. So this is how the impulse generator, you can say, functions. It's a very interesting. Uh, if you have an opportunity to visit or work in a laboratory where impulse generator is there, do take your chance to learn what is the circuitry and how does it function. Uh, this is also wrong. Yeah, this is wrong. I have taken to be R prime. Uh, uh, no, no, uh, no discharge takes place through the charging resistor R prime in each stage, as you can see it here. No discharge in the discharge circuitry. R prime is bypassed. Give a thought to it. Look at the circuitry and the connection. R prime, the charging resistor, is not in the circuit of discharge. So it is bypassed. It is connected in such a way. So R prime doesn't come into the output. I mean, it doesn't affect the output voltage at all. Next, we will see. This is a giant again, as you can see. This is a 7200 kV impulse generator, basically a lightning impulse generator. And as you see, you can even count it if you want. There are 36 stages of single circuit are connected one above the other, and each stage circuit is identical. Each stage circuit components are identical. That means you can say R prime, R1 prime, sorry, R1, R2, and mm, uh, the sphere gap construction, everything is common. Simply you make one stage and you multiply the number of stages, put them together one after the other. The voltage gets adding up for the output voltage is n times the output of first stage. It is added up. So this is having 36 stages, as you can see. This 7250, so 7200 kV impulse generator output is a new one, and these have been manufactured of this rating since something like more than 50 years, let me tell you. Another, as you see here, the just a minute. Yeah, when there are 36 stages, each stage is rated for maximum output voltage of how much? 200 kV, simply. And uh, yeah, so we have here a uh, I mean uh, this is a resistive voltage divider. Yeah, for the measurement, you can for the measurement of such high voltage, you must have provision for the measurement of the voltage of 7200 kV. How will you measure? We will go to the next chapter. When we go, I'll explain. We have normally two types of uh, two types of uh, dividers, we call it: resistive voltage divider and capacitive voltage divider. Obviously, capacitive voltage dividers are more expensive as compared to the resistive voltage dividers, but capacitive voltage dividers are more accurate because it may not the stray capacitances formed may not be that prominent in that case. So this is, as you can see, another giant. This is a, if I'm not mistaken, this is a resistive voltage divider for the measurement, and the output voltage of the impulse generator, we get it here at the from the top, and that is applied to the desired equipment, which is put at the ground level. That here should be the test object. Test object is at the ground level, and the voltage has to be brought from such a high. This is put in indoor. You have also such impulse voltage generators installed outdoors also there. So this is what is the scenario with impulse generator. I have tried to explain it to you, the function of every component. So there's just a few components and how do they function. So that makes the whole process to be very interesting. Recording the impulse voltage waveform, what you produce, you need oscilloscope and the measurement circuitry with which you can then you can confirm that the output voltage waveform is near or close to the required or what you have dimensioned by putting the R1 and R2 values, and you can imagine when you have to change in this such a high impulse voltage generator R1 and R2 in each stage, each 36 stages, how complicated would it be to change the components in every stage? And you must have a provision for that to be able to produce different wave shapes. So this is not a simple equipment. This is a very tricky, very simple circuitry, but still very complicated to understand and operate upon. Yeah, I was talking to you about how do you, yeah, we have a few minutes more. How do you set, first thing, let's talk about how do you set the gap distance in each stage. So, as I mentioned, that in the first stage, the gap distance is said to be slightly higher than the anticipated magnitude of voltage being applied. The voltage, DC voltage applied, input voltage, would be same at for each stage. But the breakdown begins from the first stage, and the gap distance is set in such a way that for the input voltage, desired input voltage, the gap distance between the spheres in the first stage should not trigger, should not lead to breakdown. That means higher than the gap distance should be higher than the breakdown voltage or setting voltage of the first stage. Then in the subsequent stages, the breakdown, the gap distances are set slightly more because you want the flashover to take place in series, that is one after the other, not together. That means in the second stage, the gap distance should be slightly higher than the first stage, so that when double the voltage across the second stage is impressed upon, minus u and plus u, as we learned in the circuit, that means 2u, only then the breakdown should occur. So the, you can say in each stage the setting of the air gap increases a little bit. That means in each stage a kind of a V is formed. So here is first stage, here is the second stage, here is the third stage. The difference is very small, and this is nothing but the stage gap distance D. This is not phi, this works out. This is not phi, this is D. That is the gap distance at higher stages. Like this. The gap distance increases one after the other stage very minutely. Very minutely. It's very small. So you can imagine in the last stage, the gap distance would be highest, and in the first stage, the gap distance D between the sphere would be smallest, because you want the circuit, the discharge of the charging capacitor should take place in series, should not take place together. That means only when the voltage from the previous stage is impressed upon the next stage, the breakdown between the two spheres should take place, which connects them all in series. So the whole process actually begins of triggering the impulse generator at the first stage. And at the first stage, some mechanism is required to begin the breakdown between the two spheres. That means the gap distance gives up, the insulating properties of the gap distance is given up first at the first stage. How do you achieve that? So the triggering process is triggering of impulse generator itself is a very, very important and very interesting gadget is required. So we call it here a Trigatron, as we call it, a Trigatron. What is a Trigatron? This is a, as you see, this is a diagram here of a sphere gap. On the right side is nothing but the sphere gap of yeah, the on the right side there is the simple sphere gap. On the left side, you the sphere is connected as you can see it here. One, yeah, the this the charging voltage U naught here is coming up to this sphere, first stage sphere. So, and the second sphere, you can say, is grounded. Normally, before the triggering begins, the second sphere is at ground potential. So, yeah, this is at ground potential initially, and this is at this is, you can say, is at ground potential, and here the high voltage is being applied at this sphere. But when you hold the voltage, the sphere gap should not have a breakdown. Now you want to produce a breakdown to put them all in, you can say the breakdown takes place and the capacitors are connected in series. So how do you do that? You do it with a device called Trigatron, and the construction, you must see the construction of Trigatron. See, there is a annular gap produced in the sphere. The spheres are hollow, and you produce an annular gap, as you can see it here. This is an annular gap produced in the through the walls of the sphere. There is a small gap, a small hole in the wall of the sphere, and from one end to the other, with the help of a bushing, you put a rod, the trigger rod, a metallic rod, with the help of a bushing. This is a bushing, as you can see, through the hollow sphere, reaching up to the annular gap. And this rod is grounded under the, it is connected to the sphere over a high resistor. And most interesting thing is this this device. What is this here? You have, in fact, the a kind of a, no, not kind of a, actual surface breakdown or surface discharge is produced over the rod. Surface discharge would produce, surface discharge. We have produced on the glass plates, and it very bright streamer and even needle corona takes place as a surface discharge over a glass plate. So you put a glass tube here instead of glass plate. Over the rod, you put a glass tube, and the other side uh, of the other electrode across the glass, one electrode is this rod, the other electrode is some metal, as you can see here, metal foil you can put uh, to ground it, and this is actually at ground potential uh, till uh, no voltage is being applied. The You can see where will be the voltage going. As you can see, the voltage going, voltage is acquired by the rod, not the sphere, isn't it? And the uh, high voltage is acquired by the rod. You keep the desired value of the voltage on this rod, and so long you keep it, no breakdown is taking place in the gap. This is the gap distance. This is the main gap distance D, what we call it. No breakdown of air taking place at D. The rod holds the applied voltage. Then you give a trigger pulse, we call it, to the rod. You superimpose with the applied voltage. Trigger pulse. And what is that trigger pulse? Of the order of, it is, trigger pulse is, I'll just write down here, trigger pulse. It's a pulse voltage once again, and that is smaller than equal to 10 kV of the shape, the trigger pulse shape with a steep front of more than 0.5 kV per nanosecond. A very fast pulse voltage, steep front of more than steep front trigger pulse of very steep front of more than 0.5 kV per nanosecond rise. 0.5 kV per nanosecond rise time. Steep that trigger pulse is superimposed on the DC voltage applied to the rod. Now, what will this trigger pulse lead to? The trigger pulse will increase the voltage on the rod and produce surface breakdown. And as soon as the surface breakdown is produced, and surface breakdown is always on the surface of the dielectric meeting the air, surface breakdown phenomenon would take place at the annular gap. And the surface breakdown is kind of a streamer, you can say, being produced here, and that streamer will trigger the breakdown between the two spheres. So that is what is done. So you can, yeah, a slight modification as I see. The high voltage is applied to the high voltage electrode, and actually this is not the ground electrode, this is the high voltage electrode, and this is actually normally put at ground potential, this electrode where the trigger pulse is applied. So high voltage is applied to this electrode, as you see in the circuitry. Please correct what I said was wrong, please correct. High voltage is applied to the high voltage electrode, as you see in the circuitry. Yeah, the upper one of the sphere gap of the first stage, and the lower one is at ground potential, which is the Trigatron, and Trigatron is given a pulse over the rod to produce surface breakdown at the annular gap. When on the opposite electrode surface breakdown takes place, the breakdown between the two spheres takes place. So that triggers the breakdown phenomenon, and when it is there in first stage, it is followed in the subsequent stages of its own. So that is the scenario. So I would make a break today here. Please mind it. What I said earlier was this is the high voltage electrode, and this is the electrode at the ground potential where the trigger pulse is being applied on the opposite side, as you can see it here. I hope you are able to understand and no confusion. In case of confusion, you must refer to the book further, because I cannot uh, have direct interaction with you to clarify your doubts. Thank you very much.